Welcome back to Sujit Patil Tech, your premier source for engineering and technology insights. In our Gear Metrology series, we've covered essential topics on all types of gears. If you missed any parts, catch up on my YouTube channel, Sujit Patil Tech. Today, we delve deeper into gear terminology part 1. Gear terminology is big subject to understand, that's why I split into parts, so first we'll understand part 1 and in next video as part 2. So let's get started. Introduction to gear terminology. The world of gears might seem complex at first glance, but understanding a few key terms can unlock the secrets of how these ingenious components work. Gears are the workhorses of many machines, transferring power and changing speed and direction. To talk about gears effectively, we need a common language. This guide will introduce you to the essential gear terminology you'll encounter. We'll explore concepts like the pitch circle, which defines the gear's size and speed, different tooth dimensions, and how clearances ensure smooth operation. By the end, you'll be well equipped to understand gear descriptions and delve deeper into the fascinating world of mechanical power transmission. Now, let's dive into the specific terms used to describe gears. 1. Pitch circle. 2. Pitch circle diameter. 3. Pressure angle. 4. Pitch point. 5. Pitch surface. 6. Addendum. 7. Dedendum. 8. Addendum Circle. 9. Dedendum Circle. 10. Base Circle. 11. Circular pitch. 12. Diameter pitch. 13. Module. 14. Clearance. 15. Total depth. 16. Working depth. 17. Tooth thickness. 18. Tooth space. 19. The face of the tooth. 20. The flank of the tooth. 21. Top land. 22. Face width. 23. Profile. 24. Backlash. 1. Pitch circle. The heart of gear engagement. The pitch circle is a fundamental concept in gear terminology. It's an imaginary circle that defines the size and speed of a gear. Imagine a gear without its teeth. The pitch circle would be the perfect circle that traces the imaginary path where the tooth profiles would precisely touch another gear during meshing. Here's a breakdown of the pitch circle's importance. Gear sizing. The diameter of the pitch circle, called the pitch circle diameter, PCD, determines the gear's size. Gears that mesh together must have pitch circles that are in a specific proportion to achieve the desired gear ratio. Speed calculation. The speed of a gear is calculated based on the pitch circle's circumference. As the gear rotates, a point on the pitch circle traces a specific distance. This distance, multiplied by the gear's rotational speed, RPM, gives the linear speed at the pitch circle. 2. Pitch circle diameter, PCD. The measurable heart of the gear. The pitch circle diameter, PCD, as we learned, is directly tied to the concept of the pitch circle. It's the measurable dimension that tells us the size of a gear based on its imaginary pitch circle. Here's a deeper dive into PCD. Definition: PCD is the diameter of the imaginary pitch circle of a gear. It's the distance across the center of the circle that the gear teeth would touch when meshing with another gear. Importance: PCD plays a crucial role in gear selection and proper meshing. Gears that need to work together must have compatible pitch circle diameters to ensure smooth operation and achieve the desired gear ratio. Measurement: PCD is typically measured in millimeters, mm, or inches, in. Calipers or specialized gear measuring tools can be used to determine the PCD of a physical gear. 3. Pressure angle. The slanting secret of gear teeth. The pressure angle is a critical aspect of gear tooth design. It's not just about the straight-up engagement of teeth, it's about the angle at which the tooth faces meet, impacting how forces are transmitted and how the gaze wear. Here's a breakdown of the pressure angle. Definition: the pressure angle is the angle between the line tangent to the pitch circle and the line normal, perpendicular to the tooth profile at the pitch point. In simpler terms, it's the slant of the tooth face relative to an imaginary line drawn along the pitch circle. Impact on gaze. The pressure angle influences several aspects of gear performance. Strength. A higher pressure angle, typically 20 degrees, creates stronger teeth but can lead to higher thrust loads on the gear shafts. Smoothness. A lower pressure angle, typically 14.5 degrees, provides smoother operation but can result in weaker teeth. Efficiency. A lower pressure angle allows for slightly more efficient power transmission due to less sliding friction. Common pressure angles. The two most common pressure angles are 20 degrees and 14.5 degrees. Today, 20 degrees is the preferred choice for most applications due to its balance of strength and smoothness. 4. Pitch point. The meeting point of gaze. The pitch point, directly connected to the concept of the pitch circle, is the imaginary point where two meshing gears come into contact. It's the heart of power transmission between gears. Here's a breakdown of the pitch point. Definition: the pitch point is the point of tangency between the pitch circles of two mating gears. It's the imaginary point on each pitch circle where the teeth profiles first touch and begin to transfer power. Importance: the pitch point plays a vital role in gear interaction. It defines the theoretical rolling contact between the gears, determining their speed ratio and the path of force transmission. Relationship to PCD: the pitch point falls directly on the line connecting the centers of both gears. The distance between the pitch point and each gear's center is equal to the respective gear's pitch circle radius. 5. Pitch surface. The imaginary landscape of gear teeth. The pitch surface, another key concept related to the pitch circle, is an imaginary surface that serves as the reference for designing and manufacturing gear teeth. Here's a breakdown of the pitch surface. Definition: the pitch surface is an imaginary surface that rolls without slipping against the pitch surface of a mating gear. It defines the ideal shape upon which the gear teeth are generated. Types of pitch surfaces. The type of pitch surface depends on the gear design. Cylindrical gear. For spur gears and helical gears, the pitch surface is a cylinder. Bevel gear. Bevel gears have a conical pitch surface. Worm gear. Worm gears have a screw-shaped pitch surface. Importance: the pitch surface dictates the size, shape, and engagement of the gear teeth. It ensures that gears mesh smoothly and efficiently. 6. Addendum. The gear tooths reach beyond the pitch circle. The addendum, a crucial gear tooth dimension, defines how far a tooth projects beyond the imaginary pitch circle. It plays a significant role in gear meshing and overall gear strength. Here's a breakdown of the addendum. Definition: the addendum is the radial distance between the pitch circle and the tip of a gear tooth. In simpler terms, it's the height by which a tooth protrudes outward from the pitch circle. Impact on gears. The addendum influences several aspects of gear performance. Strength. A larger addendum creates stronger teeth but can also lead to deeper tooth interference during meshing with the mating gear. Clearance, the addendum, along with the dedendum, depth of the tooth space, determines the amount of clearance between mating gears. This clearance is crucial for smooth operation and prevents binding. 7. Dedendum. The gear tooth's hidden depth. The dedendum of a gear tooth delves into the area opposite the addendum. It represents the depth of the space between two gear teeth, measured from the pitch circle down to the root of the tooth. Understanding dedendum. Definition: the dedendum is the radial distance between the pitch circle and the root of a gear tooth. It signifies how deeply the valley between two teeth extends below the imaginary pitch circle. Meshing and clearance. Along with the addendum, the dedendum determines the amount of clearance between mating gears. This space is essential for smooth operation, preventing teeth from scraping against each other. Strength and interference. A deeper dedendum can provide more space for addendum on the mating gear, potentially leading to stronger teeth. However, excessively deep dedendum can cause interference during meshing, where tooth tips collide before reaching the ideal contact point. 8. Addendum Circle. The outer boundary of gear teeth. The addendum circle, closely linked to the addendum, is an imaginary circle that defines the outermost limit of the gear teeth. It plays a crucial role in visualizing gear interaction and ensuring proper meshing. Understanding the addendum circle. Definition: the addendum circle is a concentric circle drawn around the pitch circle, with a radius equal to the sum of the pitch circle radius and the addendum value. Visualization: it provides a clear visual representation of the overall size and shape of a gear, including the extent of the teeth. Meshing and clearance. The addendum circle helps determine if two gears will mesh properly. Ideally, the addendum circles of mating gears should not intersect during rotation, ensuring sufficient clearance between the tooth tips. Gear design. The addendum circle is a reference point for gear designers to ensure proper tooth profile creation and avoid potential interference during meshing. 9. Dedendum Circle. The gear's inner realm. The dedendum circle, partnering with the addendum circle, delves into the inner portion of a gear. It's an imaginary circle that defines the base of the gear teeth and plays a vital role in ensuring smooth gear operation. 9. Dedendum Circle. Understanding the dedendum circle. Definition: the dedendum circle is an imaginary circle drawn around the pitch circle with a radius equal to the difference between the pitch circle radius and the dedendum value. Gear design. It provides a reference point for gear designers to define the root of the teeth and ensure proper tooth profile development. Meshing and clearance. The dedendum circle helps determine potential interference during meshing. Ideally, the dedendum circles of mating gears should not overlap to prevent the tooth roots from contacting each other. Strength considerations. A deeper dedendum circle can create a thicker tooth base, potentially increasing gear strength. However, this needs to be balanced with maintaining sufficient clearance. 10. Base Circle. The invisible architect of gear teeth. The base circle, unlike the addendum and dedendum circles, isn't directly visible on a physical gear. However, it's a crucial imaginary circle that plays a foundational role in shaping the involute profile of gear teeth. Understanding the base circle. Definition: the base circle is a smaller imaginary circle centered on the gear's axis. It serves as the basis for generating the involute curve, which forms the functional profile of the gear teeth. The magic of involute curves. Most modern gears utilize involute curves for their teeth. These unique curves allow for smooth and efficient meshing between gears, regardless of slight variations in center distance. The base circle defines the starting point for creating this involute profile. Impact on gear design. The size of the base circle, relative to the pitch circle diameter, PCD, determines several aspects of the gear tooth. Pressure angle. The pressure angle, which defines the angle of tooth engagement, is directly related to the size of the base circle. A smaller base circle creates a higher pressure angle, while a larger base circle results in a lower pressure angle. Strength and interference. The base circle size can influence gear strength and potential for interference during meshing. However, these factors are more directly impacted by the addendum and dedendum. Not directly measurable. Unlike the pitch circle or addendum circle, the base circle is not a physical feature of the gear and cannot be directly measured. Its size is calculated based on the pressure angle and the pitch circle diameter. 11. Circular pitch, CP. The spacing between gear teeth. The circular pitch, a fundamental gear measurement, defines the space between corresponding points on adjacent gear teeth along the pitch circle. It's a crucial parameter that determines gear compatibility and meshing characteristics. Understanding circular pitch. Definition. The circular pitch, CP, is the distance measured along the pitch circle from a point on one tooth profile to the same point on the corresponding tooth profile of the mating gear. In simpler terms, imagine tracing the outline of a tooth around the pitch circle and then measuring the distance to the starting point of the next tooth. Importance of circular pitch. The circular pitch plays a vital role in gear selection and operation. Gear meshing. Gears with the same circular pitch will mesh properly, ensuring smooth and efficient power transmission. Gear selection. When selecting gears to work together, their circular pitches must be compatible. Gears with different circular pitches won't mesh correctly and could lead to binding or damage. Gear size and number of teeth. The circular pitch is related to the gear's diameter and the number of teeth. A larger gear with more teeth will typically have a larger circular pitch. Relationship to other parameters. The circular pitch can be calculated from the pitch circle diameter, PCD, and the number of teeth, Z, using the following formula. Thanks to watch my video. If you like this information, just like this video, and for such kind of information subscribe my YouTube channel Sujit Patil Tech. To continue gear terminology learning, watch my next video Gear Terminology Part 2. Thank you.